Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello students, subscribers, and viewers. Here are another two problems in calculus, and I hope that you will have the time to appreciate the presentation and hoping that you will improve your skills in calculus. So here are the two problems. Evaluate limit as x approaches 1 of cube root of x minus 1 all over square root of x minus 1. I will present the proper solution, and the second one I'll give you the hint, the technique on how to evaluate this for just knowing the answer for purposes. Then find the numbers a and b such that the limit as x approaches 0 of the quantity square root of quantity ax plus b minus 2 all over x as x approaches 0 is 1. So for the solution of the first problem, so the LCD of the indices is one is 3, the other is 2, so 6. So we will transform this in such a way that there is a common factor which we're going to remove, that is x to the 1 6 minus 1. So we write the numerator as x to the 1 6 quantity square minus 1 square, while the denominator we write this as x to the 1 6 quantity cube, so that x to the 1 6 quantity cube is x to the 1 half, which is the same as square root of x minus 1 cube. Anyway, 1 cube is still 1 and 1 square is still 1. So we have limit as x approaches 1 of x to the 1 6 quantity square, or x to the 1 third minus 1 over x to the 1 half minus 1. Since the LCD, least common denominator of the indices, is 6, then we're going to transform the numerator into limit. So we have limit as x approaches 1 of quantity x to the 1 6 square minus 1 square. And the denominator as x to the 1 6 cube minus 1 cube. So take note that x to the 1 6 square is the same as x to the 1 third, or cube root of x. Then minus 1 square, that's still minus 1. Then in the denominator, x to the 1 6 cube, that's x to the 3 over 6, or x to the 1 half, which is the same as square root of x. Then minus 1 cube, which remains 1. Then we have the guide from factoring techniques. We have difference and sum. So x minus y, x plus y is x squared minus y, or x squared minus y squared is x minus y, x plus y. That's the factoring difference of two squares, and factoring difference of two cubes, x cubed minus y cubed is equal to x minus y times the quantity x squared plus xy plus y squared. So imagine that here x is x to the 1 6 and y is 1. And in this factoring guide, x is x to the 1 6 and y is also 1. So in the numerator, we write that as x to the 1 6 minus 1 times, so we have limit as x approaches 1 of the quantity x to the 1/6 minus 1, then times the quantity x to the 1/6 plus 1. Then in the denominator x to the 1/6 minus 1 times the square of x to the 1/6, which is x to the 1/3. Then x to the 1/6 times 1 is x to the 1/6. Then 1 square is still 1. So from here, because x approaches 1, we can now cancel x to the 1/6 minus 1. Then this fractional expression is now free of 0 as x approaches 1. Unlike before, we have as x approaches 1, the numerator approaches 0 and the denominator also approaches 0. So that means the that is indeterminate form because we have 0 approaching 0 over approaching 0. So this time we are free to substitute x is 1. So that would be limit as x approaches 1 of x to the 1/6 plus 1 all over quantity x to the 1/3 plus x to the 1/6 plus 1. So this is now free of 0. We substitute x is 1, and that would be 1 to the 1/6 plus 1 over 1 to the 1/3 plus 1 to the 1/6 plus 1. And since 1 to the 1/6 is 1, 1 to the 1/3 is 1, 1 to the 1/6 is 1, so that is 1 plus 1 all over 1 plus 1 plus 1, and that would be 2/3. So therefore the answer is 2/3. The other advanced solution would be applying L'Hopital's rule. So because this is of indeterminate form, the derivative of x to the 1/3 minus 1 is 1/3 x to the negative 2/3, and in the denominator 1/2 x to the, so the numerator 1/3 x to the negative 2/3, the denominator 1/2 x to the negative 1/2, which simplifies to 2/3 x to the 1/6, and when x is 1, 2/3 times 1 to the 1/6 is still 2/3. So that's the other solution. The third one is for your board exam. For board exam purposes, use your calculator. All you have to do is substitute two values of x. One is to the left of 1, which is 0.99999. So I suggest substitute value to 5 decimal places, 0.99999, and the other one 1.00001. If the two give you a value almost equal to 2/3, then the limit exists and the final answer is also 2/3. So that's the other way. Then let's proceed to the second problem. Find numbers a and b such that limit as x approaches 0 of square root of ax plus b minus 2 quantity in the numerator over x is equal to 1. So because it has radical there and we have a denominator which is x, normally or in a usual limit problems, x should be cancelled and the numerator should be free of any other terms except ax, so that x can be cancelled. So first step is to multiply and divide this expression by the conjugate of the numerator. So limit as x approaches 0 of quantity square root of ax plus b minus 2 over x, then times quantity square root of ax plus b plus 2 all over square root of ax plus b plus 2, which is the same. And recall that from this product of this is x squared minus y squared. So this is limit as x approaches 0 of ax plus b minus 2 squared or minus 4 all over x times quantity square of quantity ax plus b plus 2. Since the only way we can cancel x is these other two terms should be not around, the numerator should only be ax so that we can cancel x as x approaches 0. So that means b minus 4 equals 0. So if b minus 4 equals 0, then we can now find b. b should be equal to 4. Then this problem reduces to limit as x approaches 0 of ax over x quantity square root of ax plus b plus 2. So take note that b is found and it is equal to 4, has been found and it is equal to 4. So we can cancel x. That reduces to limit as x approaches 0 of a all over quantity square root of quantity ax plus b closed then plus 2. And the limit should be equal to 1. So we can now substitute x is 0, so a times 0, then b is 4, so that would be a over square root of a times 0 plus 4 plus 2 equals 1. Then square root of 0 plus 4 is 2, plus 2 is 4, so a is 4 times 1. So a must also be equal to 4. So that's it for this problem. You can check if you substitute a is 4, then b is 4. As x approaches 0, you can evaluate that the limit is equal to 1. Even if you substitute a value of x, which is just to the left, negative 0.00001, and just to the right, positive 0.00001. And when a is 4 and b is 4, both will give us a value which is equal to 1.